Outer join. Here's a question. What if I also need the rows that don't match? That's a good question, right? You see, with the inner join, we answered the question of what is the intersection I'm looking for? What is the correlation? What is the subset of data that I need to answer my question? And now the question becomes, what if I also need all the rows that don't match? What if I also want to see those? You see, with our filter, what we basically went towards is that middle point. And what outer joins try to do, as opposed to inner joins, is also take into account everything outside of that inner puck that we were looking at. Outer joins add the data that don't have a match. Now, what does that look like? Well, let me tell you something. There are two types of outer joins. Remember when I told you that when you join data, you have to decide what table is going to be on the left-hand side and what table is going to be on the right-hand side? Well, there are two types of outer joins. There's a left outer join and a right outer join. Now, with the inner join, we were aiming for this golden intersection. We just wanted the things that matched our join. Now, what a left outer join does, or a left join, we also call it a left join, is you can see here that I've highlighted table A in blue. Well, a left outer join adds the data that doesn't have a match from table A, from the table that we put in the from clause. When we talk about on the left-hand side of a join, we're talking about the table that is in the from statement. When we talk about the right side of the join, we're talking about the table that is being joined. So when we do a left outer join, we're joining the data that doesn't have a match for table A. Now, the syntax looks something like this. Select star from table A as A, and then you can decide. This is just a matter of preference. You can type left outer join or you can type left join. They mean the exact same thing. Some people prefer to type left join. Some people prefer to type left outer join. Decide which camp you want to be in. It doesn't really matter at the end of the day. So you left join table B as B. And we use the same syntax. On A.id is equal to B.id. Now what this left join is going to do is it's going to say, okay, let me find everything where A.id is equal to B.id. That golden intersection we talked about, that the inner join gives us. But what the left join is also going to do is it's going to say, well, everywhere where I couldn't find an A.id, I'm just going to return that data to you. I'm just going to show you those rows. Some values may contain null because you can't find a correlation with B. Some of those columns that you're trying to join with, they may not have a value. They may be null. And we know from the three-valued logic, nulls are a contentious thing. But it's okay when you're joining because we can coalesce. We can value substitute. So any value that does not match is made to be null. So let me give you a problem statement. What if you wanted to know how many employees aren't managers? What if that was the question? How many employees aren't managers? Well, here's a query for you. Select count emp.employee number from employees as emp. And we do a left join on the department manager table. And we're going to call it as dep. And we're going to say on emp.employee number is equal to dep.employee number. So from our inner join, we know that that golden intersection is going to be everyone that is a department manager. Now, here's the nice part. Because we're doing a left join, that golden intersection we talked about here is emp number is equal to dep emp number. So those are all the department managers. But because we're doing a left join, we're also getting all of the people that aren't department managers. So we can say, hey, on top of us doing that join, filter out all of the ones that are null in department employee number. So when we do the join, we're going to see that a bunch of them are going to be null. So let's go look at that real quick in Valentina Studio. So here we are in Valentina Studio, and you can see part of the query that we're talking about here. So if we execute this, we can see that the left join has a bunch of null values because not every employee is a manager. So a bunch of them aren't managers. So there are a bunch of null values. So who is a manager? Well, let's take a look. We can use the where clause to filter where dep.emp number is not null. And if we execute that, we'll see that we have 24 managers. So 24 of those people are managers. Okay, that's easy to count because we can just, there's not a lot of information. But if we did is null, now we can count on emp.employee number. And what we'll see is we'll actually get the count of the amount of people who aren't a manager, which is 300,000. So the left join allows us to take into account everyone that didn't match against department manager. Now you could have done this in multiple steps with multiple queries and done a subtraction on your calculator or whatnot. But what we're trying to get here is in the groove of allowing SQL to do the hard lifting for us. And for that, we need to know a couple of basic concepts. How to work with the data, what exactly we're looking for, and how that can work in our benefit. Now that we know how the left outer join works and how it can benefit us, what if I gave you a different problem statement? What if I told you we want to know every salary raise and also know which ones were a promotion? You see, our previous query, we just looked at, hey, these ones are promotions and these ones were the base salary, the salary they came in at. But what if we also wanted to see every other raise that wasn't a promotion? Well, let's take a look at that. All right, so over here we had our original query, which was the two inner joins. And we inner joined employees on salaries and titles, and we had the original salary that they came in at and the original title. And if they had ever gotten a promotion, we also had that salary and title. Now, what if we wanted to also include all of the salaries that didn't account for a title change? How would we do that? Okay, well, let's think about this logically. So we want all of the salaries that didn't account for a title change. So we don't want to be strict on the titles. So let's make that a left join. And let's see what happens. So what we can see here is that we're expanding that golden intersection to also include all of the salaries that aren't necessarily linked to a title or a from date. If the employee number for some reason doesn't match on top of this statement, we're still going to see it. So now we can see all of the raises that an employee ever got up until the point that they became a senior engineer, for instance. You can see here coming in as an engineer and becoming a senior engineer, there were quite a few raises for 10,004. All right, so now that we know that, we know how left joins can be powerful. And we could even go so far as to coalesce the title and say, if it is null, no title change. And that just adds to making the data a bit prettier. There we go. All right, so here we can see a more elaborate solution than the one I just showed you. But what we're basically trying to accomplish here is trying to say, hey, when a join is trying to allow all of the things on the left side to be included that may not align with the specific join, that's what a left join is for. It's saying, hey, everything that is null on the left side, if it doesn't match this criteria, just show it as well. So we're showing everything that is also not linked to specifically a title change, because title changes only happen with raises or when you join the company. But raises aren't linked necessarily to title changes. So we're seeing all of the salaries linked to that person, and specifically when that salary was linked to a title change, when they came into the company or when they got a promotion. Now feel free to pause the video and go execute that query and play around with it. And you can see when their title changed. And you can see over here the coalesce function. So we didn't add in our alternative column value for this one. Now, you may ask yourself, okay, we saw left outer join. What are right outer joins? Well, right joins add the data that don't have a match from table B. So on the right side of the join. If something in title didn't match what came out of employee number in the employee table, we'd see all of the null values for table B. It's basically the opposite of a left join. And it basically has the exact same syntax as a left outer join, except it uses right outer join. So with that, you now basically know the difference between right outer join and left outer join. They are the inverse of each other, but one acts against the table that is being joined and the other acts against the table that is joining. So for instance, the left outer join goes against the from statement. The right outer join goes against the table that is being joined, the table that is in the join statement. Any value that does not match is made to be null. Again, exactly the same like a left join. Now, let's take a look at some of those joins that you won't see very often.